In this video, we'll write the balanced net ionic equation for AgNO3 plus Ki, silver nitrate plus potassium iodide. First thing we need to do is balance the molecular equation. This is the molecular equation, and it is already balanced, so that's kind of nice. Then we need to write the states. So if you know your solubility rules, nitrates are very soluble, so they'll dissolve in water, dissociate into their ions. We say they're aqueous. In general, compounds with group 1 elements like potassium are soluble, so we're going to write an AQ after that. They'll dissolve, dissociate into the ions. Compounds with iodine are in general soluble with some exceptions. Silver is an exception. Things like silver chloride, silver iodide, they are not soluble. So since they're not soluble, they won't dissolve. They'll stay as a solid. So this is a precipitate. When these two react, this is going to fall to the bottom of the test tube as a solid. We said nitrates, very soluble, write a little AQ there. So now that we have our states, we can split the strong electrolytes apart into its ions. And when we do that, we get the complete ionic equation, sometimes called the total ionic equation. So silver is always 1 plus, the nitrate ion always 1 minus. So we have Ag plus, and I won't write aqueous each time. Let's do that at the end. Plus the nitrate ion, NO3 minus. Potassium, that's in group 1, so that'll have a 1 plus charge. The iodide ion, that's a halogen, group 17, 7A, that's a negative. So we have K plus that iodide ion, and those are the reactants. For the products, in net ionic equations, we don't split solids apart. So we're just going to write AgI, silver iodide, plus, we have a plus and a minus, K plus, potassium ion plus the nitrate ion. So this is the complete ionic equation. And once we have the complete ionic equation, we can cross out spectator ions. So these spectator ions, they appear on both sides, in the reactants and the products. In essence, they don't change, so we're not interested in them. As I look, I see I have a nitrate ion in the reactants and in the products. So I'm going to cross that out. Same for the potassium ion. Here it is in the reactants and here it is in the products. But everything else is unique. So that leaves us with our net ionic equation. Ag plus I minus, that gives us AgI. Let me clean this up a bit, and then we'll have our balanced net ionic equation for silver nitrate plus potassium iodide. And this is the balanced net ionic equation for AgNO3 plus Ki. You'll notice that the charge, that balances out, so we have a neutral compound here, and we have the same number of atoms, each type of atoms, on both sides, so it's balanced that way as well. This is Dr. B, and thanks for watching.